Hello and welcome to this Science mini-masterclass. This is part 2 of my little series on how to use the physics formulas to approach non-calculation questions. In this session I'll be focusing specifically on how to approach some of those juicy 4, 5 and 6 mark questions related to the required practicals in GCSE Physics. As always, aim of the game, help you secure the knowledge and apply this effectively to exam questions. Let's get cracking. So, just a quick reminder to begin with, if you're wondering what I mean by physics formulas, it's these ones here from the Edexcel GCSE Physics exams, and these ones here are an example of ones from the AQA physics papers. Again, these are going to be provided in exams for 2026 and 2027. Yet to be confirmed on whether or not you'll get the full equation sheets in 2028 onwards. So the techniques that I'm going to share with you today can be applied to pretty much every single physics required practical or core practical if you're an Edexcel student, to help you structure your answer and obtain the most marks possible. And those are some examples there on the screen of the different physics required practicals that we can use this technique. So I'm just going to show you then to begin with how I'm going to use the physics formula sheet to approach an exam question. In this case, I'm being asked to describe how a student could use the equipment shown in figure 4, which is here, to determine the specific heat capacity of vegetable oil. Now, specific heat capacity by definition is the amount of energy to increase the temperature of 1 kilogram of a substance by 1 degree centigrade. If you've forgotten that, it doesn't matter in this case because we're going to use an equation to help us answer it, not the definition. So, first thing I would do, look at my physics formulas sheet, and I'd find an equation like this one with specific heat capacity in it. So that's the quantity that I need to be able to calculate through a series of measurements using the equipment shown in figure 4. So to begin with then, if I'm trying to determine the specific heat capacity of vegetable oil, I'm going to need to measure the mass of that vegetable oil. So I'm going to place the beaker on the top pan balance, which is scales, and set it to 0. And then I'm going to add my oil to the beaker and measure the mass using the top pan balance. And ideally I'd have a mass of 1 kilogram because that relates to the definition of specific heat capacity. Tick. I've ticked off which quantity in the equation I've already talked about measuring and what equipment I would use. Next, put the thermometer in the oil and measure the starting temperature. Okay, so I'm looking at temperature change now. I'm not going to tick that off just yet though, because temperature change is obviously going to require the temperature to be measured twice and then the difference calculated. I'm going to put the beaker of oil on the electric heater and turn it on because obviously I'm going to need to start transferring some energy to it. So that's going to be via the electric heater. I'll measure the energy transferred using the joule meter. Okay, obviously energy is measured in joules, and I can see J, the unit there, J, for joules on the joule meter. Notice it's the energy transferred using the joule meter, not the change in thermal energy. Okay, because the energy transferred over time will give me that value. Okay, because however much energy I transfer from the electric heater will be used as my change in thermal energy of the oil. Tick that one off. When the temperature of the oil is increased by 1 degree centigrade, so I've referred to temperature again, and that's the change there, 1 degree centigrade, I would then turn off the electric heater and then I can calculate the specific heat capacity by rearranging that equation as shown here. I've mentioned the temperature change and I've mentioned the specific heat capacity. So I've built my entire answer around that equation, and all I've done is refer to the quantities and how I would measure them with different bits of equipment. Now that's a model 6 mark answer. If that wasn't structured particularly coherently and logically, as long as I mention how I'm going to measure that with what bit of equipment, how I'm going to measure that with what bit of equipment, and how I'm then going to measure the change in thermal energy, i.e. the energy transferred, again, with an appropriate bit of equipment, I can pick up at least 3 marks just from that without it being nice and logical and coherent in its structure as shown here. One more for me to demonstrate to you. In this case, we're looking at the wave speeds required practical, investigating wave speeds in solids, or in this case, a liquid. And I've been asked to describe how the student could determine the speed of a wave on the surface of the water in the ripple tank. Now, a lot of students really struggle with this required practical. Okay, it's quite difficult to get your head around how the different bits of equipment are actually used to obtain the quantities needed to calculate wave speed. Notice it's not just the equipment in figure 5, it's any additional equipment that I may need. Now there's 2 different methods I could use for this because there's 2 equations with wave speed in. I'll show you the first one, the easier one. I choose an equation that has wave speed in. Wave speed equals distance divided by time. I actually get a mark for mentioning that. Next, how am I going to measure my distance? Well, I'm going to measure the length of the screen using a ruler because I'm told that the waves are going to be shown as shadows on the screen below the ripple tank due to the light source above. So I'm taking my measurements from down here. Tick off distance. I've mentioned that. Next, I'm going to video the shadows of the waves moving across the screen because it's very difficult to keep track of one wave in live time, okay, even if I am looking at the screen. So I'm going to video it and then I can obviously play that video back as many times as I like and time how long it takes for one wave to travel the distance across that screen. I've mentioned time. I've got 4 marks so far. 5th mark, repeat and calculate the mean time taken. That's always a good statement to make at the end of a practical method because as long as you've written a reasonable method, you're going to get a mark for that at the end. And notice it's repeat and calculate the mean time taken. We won't get a mark just for saying repeat. Okay, so there, 5 marks. Method 2, this one, I could also use wave speed equals frequency times wavelength. Okay, so I'm going to place a meter ruler next to the screen for measuring the wavelength. Okay, and I'll explain how we'll measure the wavelength in due course. That's my additional piece of equipment mentioned there. I'm going to video the waves, or the shadows of the waves, traveling across the screen. Again, I can play that back as many times as I like and pause a video as well so that I've got a fixed image to take measurements from. I will count the number of waves reaching the end of the screen in 20 seconds, then divide by 20 for the frequency, because remember, frequency is the number of waves passing a particular point per second. If I didn't say the end of the screen, I could have said mark a point on the edge of the screen and count the number of waves passing that point in 20 seconds and divide by 20. Okay, you could have done 10 seconds, 30 seconds, it doesn't matter. As long as you divide by the number of seconds, you'll be getting the frequency. I've mentioned frequency. I've ticked it off my list. Next, wavelength. Well, I've got my ruler there next to the screen. I've obviously videoed those waves moving across the screen. So I'm going to pause the video and I'm going to measure across several waves and divide by the number of wavelengths for wavelength. That's far more accurate than trying to measure the distance between one wave and the next for wavelength using the ruler. And finally, repeat and calculate the mean. So I've actually got 6 different good points there and I only needed 5 of them to get 5 marks. Okay, so those are 2 different methods I could have used. Again, building the answer around the equations. Okay, so even if you forget the method, find the equation, mention the quantities and how you'll measure them. Okay, here's one for you to have a go at. We've got a different scenario, different required practical being looked at here. Pause the video, have a go at this, and I'll review in a moment. Right then, So this was about investigating the acceleration of a trolley. In this case, it's rolling back down a track. And all you've got to do in this one is determine the average speed. So not even calculate acceleration, even though it relates to that required practical. You get a mark for choosing an appropriate equation and including it, I recommend, at the start of your answer. Doesn't matter if you've put it at the end though. Mentioning how you'll measure the distance, i.e. the length of the track, using an appropriate piece of equipment such as a ruler or tape measure. A third mark there, how you're going to measure the time and what time as well. You can't just say measure the time. It's the time taken for the trolley to roll back down the track. Again, appropriate piece of equipment using a stopwatch. And a fourth mark again for repetition and calculation of, in this case, the mean time taken. Okay, you wouldn't repeat your measurement of the length of the track and calculate a mean. That's not going to vary significantly based on the impact of random error. Time, though, could be affected by random error and the use of the stopwatch. 4 marks, again, built around an equation. And finally, there's just one more example for you there. In this case, it's the density required practical. And I'm not going to talk through the whole method, but hopefully if you pause the video, you'll see that all of these marking points here, they are built around the equation for density and how the different quantities could be measured. And that, again, a 6-mark question. So we're talking a lot of marks for these. And that's a wrap. Okay, that's part 2 of 2 of this little series on how to use physics formulas to approach non-calculation questions. If you found that useful, please do hit the like button. And for more Science Mini Masterclasses, please subscribe to my channel, Science Mini Masterclasses. I'll see you in the next one.